So I will ask you to please go and open the software. When the software opens, you can access, just gonna dismiss here. So the software will open in an interface like this. Okay. It might open different to you. It depends what version you are running. I'm running an old version, 13. You might have a different version. So I was saying you have here the material so you can have further information. I'm just gonna show you the software for the purpose of the design consistency today, but you can also forecast collisions and check policy from the AASHTO and Federal Highway Administration perspective. So we're gonna select the create new project, please. Can you guys see this window?
Yes.
Okay, so please go and select create new project. We hit next. You can call the project whichever way you want. I'm gonna say September 25th, 2020. Be careful. By default is on imperial units, but we want metric. So you have to change it to metric. All right, hit next. We are not gonna import a highway. We're gonna create a highway. They have a sample highway, but you can look at that one later on. We're gonna create a new one. Click on next. We're gonna call this highway, I don't know, highway 20 maybe, something like that. You can assign the name of the actual highway when you are working on it, but right now it's an academic example, so you can put any name to the highway. Click next. So this is gonna create a metric, it's gonna call it this way, and we're gonna hit on finish. It's gonna open the wizard. It's gonna ask you in this screen to select the maximum super elevation. We have not covered yet the super elevation. You might have seen super elevation previously in CV 372. I am not sure, but this is simply the cross slope that you will do in a horizontal curve so that your curve, the centripetal acceleration is counteracted. So to be on the safe side, you can just choose the maximum and then you can select for every section whatever you have. This is just to limit the ability to the maximum depending on the type of facility. So if you are not sure, you can just select the maximum. We can adjust it later. And this is the cross slope. This is just for the drainage. So we can keep it in -2, that's fine. Typically we use -1.5. Click on next. Now, this one is if you want to use equations. I really don't advise use equations. Yes, go ahead.
Which slope did you choose? Minus 1.5? Minus 12. Oh, okay.
This is
so there's two. Okay, okay.
Yes.
And the other one is minus 1.5?
Yes, but this one is for drainage. I keep it in. I kept it as -2%. But you can if you want, you can change it and say -1.5. This will replicate whatever you have in your design, because we don't have a full design and I'm actually trying to show you. So we're gonna make some assumptions, right? This one is super elevation. So this one is for the vertical curve to compensate for the vehicle trying to exit the road. Here, I was saying, don't use equations. I don't recommend you use equations. It's rather difficult. It's not easy. We're gonna input the alignment later on. So just click next. Now, we need to define the starting station, the ending station, and several things. So if you already have your 29 kilometers segment, you will code it like this. You will say starting station is 0, ending station is whatever is the maximum alignment you have. I think you guys have segments that are somewhere between 29 and 31 kilometers. It depends. The segments are not the same size. And when you are reading the information, because it's approximate, segment might shrink a little bit. But you will write 29,000, right? If you have 29 kilometers. The heading station is, you can see here a little help, but is from where I start moving on. So, and typically we start moving from station 0, right? And then the heading angle, so that means if station 0 is here, maybe I need to put a PowerPoint. So I'm gonna have my starting station here. And then I'm gonna start moving north. If I select 90 degrees, so this will only affect the visualization of the road. So this is 90 degrees. And the elevation, if you happens to know what is the actual elevation, then you write 653 meters above sea level, or 1,500, or whatever it is. In my case, I don't know, so I'm just gonna say the elevation is 1,000, because I don't have the elevations. I'm gonna use a fictitious segment of road to show you this. And as a matter of fact, I don't want to complete 29,000, so I'm just gonna put 3 kilometers for my road segment. But this is just for the segment I'm gonna show you, okay? If you guys want to do this straight for your final project, then you write here your 31,000 meters, if that is the length of your segment. So you will type here the length of your segment, right? Let me just put a 1,000 meter maybe for me. Is this clear so far?
Yes.
Okay. So now I need to define what type of area this is. If it is rural, urban, suburban, okay? So you click add, and it's gonna say from station 0 on is gonna be rural. You say, okay. If it happens that at some point change, then you click add again, and now you type from one stations on is gonna be different. Let's say from station 1,500 on is suburban, maybe. The functional classification is whether this is expressway, arterial, collector, okay? To me, I'm just gonna keep it as arterial. I'm not gonna complicate, but you will go and select whatever it is that you have. And again, it can be an arterial up to some point in the station, and a different point, maybe in the kilometer 2, it changed into a collector, and you can do that type of definitions, all right? I'm just gonna keep everything as one arterial, and I'm gonna keep everything as rural. The alignment type. So from station 0 is the same concept. Whether is undivided 2-lane, undivided multi-lane, divided multi-lane, okay? So I'm gonna use an undivided 2-lane for this example. You have some help here on the left. I don't know if you notice. What is the width of the lane? Well, we will prefer the 3.65 meter lane, right? If there's a transition, let's imagine no. The median, we can keep the 1 meter as median. This one is important. Whether it's a transversable median or non-transversable median. Non-transversable median means that if you are driving in one direction and you wanna get into Tim Hortons, but Tim Hortons is on the left, you cannot go over and turn left. You will have to go to the next intersection, make a U-turn, and come back, because there is a jersey barrier, or there is a guardrail, or there's something in the middle that is dividing physically the road. If it is transversable, that means there's only a pavement marking and you can go over it. So I'm gonna keep it as transversable. I'm gonna click on next. Yes, 7 questions. Okay, questions are for Arash. Yeah, Civil 3D, GIS, User Lab, yes. Okay, so nothing for me? Apparently not.
Professor, I'll take care of questions.
Okay, thank you. So this gives you a summary. So we're saying this is rural, arterial, 2-lane, start here, finish here, all right? And we can start the highway editor if we check this box down here. Otherwise, you have a menu here, so you can also access your highway editor from here. So let's imagine you forgot to check the box for start the highway editor and you click on finish. So this assessment will be for the highway, but my highway is kind of empty. My highway is here, you see? It was created here. I can actually go and expand, and I can actually go and hit here and click on edit highway, okay? This is the highway I'm defining. This window that you have here, we're gonna use it in a moment, but we still need to input some information. That's what I'm trying to tell you, okay? So far, we have not defined the horizontal curves and all that, the radius of curvature, okay? So we need to do that. And also we need to define some extra elements, speeds. So you can come here and make a right click and say edit highway. Or you can just click here on the highway you want and you come down here and you say edit highway, okay? And this window will pop up. Can you guys see this window?
Yeah.
Okay. So we have the different elements that we need. We need horizontal alignment, vertical alignment, the lanes, and so on and so forth. This is for a crash prediction data. Click on the drop-down menu and select the design consistency data. It is less items that you require. If you want to go for a crash prediction, you need all these items. So you need to put site-specific crash data if you have, rumble strip info, this lighting, road safety hazard rating, driveway densities, etc. But, and there's other analysis, right? There's also the policy review, the crash, the traffic analysis, but we're gonna look at the design consistency today.
Sorry, Prof.
Yes.
Yeah, so I'm one step behind you. Just to be sure, for the nominal true lane and all, like in this page, did you keep everything as like the same? So let's say it's
Nominal
12.
2-lane.
It's 12 feet.
12 feet. No, I changed this to metric. You didn't change to metric?
No, I didn't.
So in that case, you can keep the 12 feet if you want.
Okay.
That was an important step because otherwise you are stick to imperial units. Unless you like imperial units, then there's no problem.
I mean, our project is in metric, right? It's in
Yes, of course, Canada is in metric, but the software is from the US, so they still like to use the imperial, although they are officially metric.
Okay.
So I was saying, the rest of you have arrived to this window when you can see horizontal, vertical alignment, and so on?
Yes.
Okay,
No,
so
I'm
please
still
click on the
at
horizontal alignment. Go ahead.
I'm at the same part of the guy that spoke. Because my computer lagged, so
Here?
No, I'm at the nominal true lane.
Yeah, I cannot go back anymore. So just keep the defaults that you are looking at.
Sorry?
Just keep the default values. I'm just talking to somebody who is still behind us. And so just keep the 12 feet and all the default values that is giving you. Will I restart? Okay. Okay, so edit highway. So please click on horizontal alignment. As you can see, the horizontal alignment is going from station 0 to station whatever the number you wrote to be the final as one tangent, because we have not input yet what is the actual alignment that we have. If you remember from the class that we did last time, we had defined some information for the highway, right? Or alternatively, I can open another one here, one moment, and I can show you a different one that has a horizontal alignment. So you remember we need this format, right? So the format that you have gone and collected from ArcGIS is the one that will preserve this. So you will have the type, whether it's a tangent. Just gonna insert here. So you already did this, okay? Your starting station, your ending station, your radius of curvature, the direction of the curve. Okay, so if it is a tangent starting on 0 and maybe finishing on 500, maybe the next one is a curve. You can see there a curve. Maybe it's starting in 500, maybe it's finishing in 1000, and maybe has a radius of curvature of 325, and maybe it is to the left. And maybe I have a tangent after that, starting in 1000, finishing in 1750, with a radius of curvature of maybe 250 to the right. And maybe I have, a curve. And maybe after that, I have a tangent that is going from 1750 to 3000. And so it doesn't have any of that. So you guys will have something like this, okay? Of course, you have more entries, but what you do is you go and you highlight from your Excel and you say Control Copy. If you don't have anything, because you didn't have time to prepare it, then you can just produce or copy the one I just produced on screen. I think I hopefully will work. Is there anybody who is lost, or we are all okay? You remember we did this last time in ArcGIS, right? And we transferred the info to Excel. Now we're gonna come here to the one we were coding, which is this one. And I'm gonna delete this one. I'm gonna say okay. And then here on top of the add, you see this button that is add? On top of it, I make a right click. It's not a left click, it's right click. And in the right click, I say paste. Right click and paste on the add. I'm gonna just wait a minute. I hope, let me know if you were able to do it.
Yeah, it worked for me.
Okay. I still need to enter other information, but I'm just gonna save for a moment so you understand how you see how we save. So you click on File and we hit Save.
Sorry, Professor, I have a question.
Yes.
When I clicked on paste, it gave me an error because
Because you didn't delete the previous row, probably.
No, I deleted it as well.
Okay.
But maybe because we chose the height, it shows the way, not the height, sorry, the segment of the length. It's way too much. It's giving me a lot of errors.
Did you, when we were creating this at the beginning, that I told you, you have to enter the exact length of the highway you want to create. Maybe that length doesn't match the length that you have here.
Is it possible to change it now? Or like we have to go all the way back?
Adjust the last segment so that it match. I suppose it's not much the difference, or is a lot?
I put it, we only put like 3 kilometers. It's like 31 kilometers.
I
Yeah.
explained that I will use 3 kilometers for my case, but if you had done the Excel, you should use the 29, 30 kilometers, 31 kilometers, whatever that was. So there's a lot, because then it's 3 kilometers to 30 kilometers.
Yeah, that's
The
why I'm
best-
having it. Yeah, sure.
The best you can do is just close it, reopen again, and put the right length now.
I'm sorry, so you can change the length. If you go on the drop-down menu on your left and you go Alt Data, you can change the segment length. No, wait, it says design consistency data.
Yeah, but we need to exit this one, right?
You didn't need to. You just go to all data and like change the max station, and like it should be all right.
Okay, so you have an all data. Okay, thank you very much. Thank you for that. So that will be here, right? Is the boundary of the horizontal alignment. So just change this one to match your length
No, I don't have. How did you get this table again, please?
here on the drop down. Select all data.
I have to close the horizontal. Because I have error, I can't close it.
Then cancel what you were doing. Or put the number, put a tangent, erase everything and just put one tangent from 0 to 3000. Okay, in the meantime, for those of you who had saved it, we still need to input other information. So please go back to the design consistency. And so we entered this. So if you want to just visually check, you come here to view highway on the left, on the bottom left. Click on that and it's going to show you like a representation of the plan view of the highway. Okay. Of course, I define anything, right? So I define one curve, one tangent, one curve, and one tangent. In your case, it's going to look different because you probably use the one you have collected in Excel last time, unless you're using the same that I'm using now. But this at least confirm that what I have is correct. I'm just wondering if I can't remember who was having difficulties with the length, the maximum length. Were you able to close it and change it?
I'm working on it.
Okay.
Sir,
Yes.
I get a error of that says overlaps element.
Overlaps elements.
Yep, between a curve and a tangent.
Is the ending station the same as the beginning station of the next one for
Yep.
all of them?
Yep.
Is this maximum tangent station or maximum, the last station, the ending is also the boundary that you have for your horizontal alignment?
Yes.
I will need to look into your data. So just give me a second. I'm gonna let you share. Okay, so now let's click on the vertical alignment. The vertical alignment has been defined as flat. From the beginning to the last station, 0 grade, so it's perfectly flat terrain. Just for the purpose of this class, I will keep that, but if you ever want to change that, then it's gonna look like this. You will have to enter your points of vertical intersection. And for every point of vertical intersection, you enter what station that point is, what is the back grade, the back length, the forward grade, and the forward length. For the purpose of this example I'm doing today, we're going to assume it's perfectly flat terrain, so we're not going to worry about that. And I am here on design consistency, but it's the same. So this means, you remember in class we did model 1 and model 2. Model 1, I told you, is perfectly flat. So that's what we are doing right now. Double click on design speed. Once you click on the design speed, we're going to enter a design speed. So let's say add starting station, ending station, and what is that design speed in kilometers per hour for those of you who selected kilometers per hour. So I think maybe we can try 60 or 70 kilometers per hour. Let's go for a 60. You click on add. Of course, if your speed changes and you know that, then you can use the stations to enter where the speed is changing, right? I'm just gonna delete this one and show you again. So if you know that you have a certain speed from station 0 to station, let's say 1,500, you have 60. You say add. And you know from that station to the next one is 70. Then you can define it, right? You can define the variations on speed if you need to. Posted speed. So let's go ahead and click on posted speed. We click on add. Now, this is the posted. This is what is on design. Okay. Again, you can define it on different segments. So let's imagine the first posted speed. The design is 60, but the posted is 50. And for the second segment, the design is 70, but the posted is 60. Let's just assume that. Just gonna wait a minute. And you guys let me know if you are following, please.
I don't have the option of posted speed.
Have you selected here design consistency data, or are you using another one?
I'm gonna check. Okay, good.
So you were somewhere else, right?
Yeah.
Yes. Okay, so the next one will be desired speed. Remember, this is the VF we covered in class. And we said that desired speed is off-peak, free flow, unobstructed movement. And it's basically coming from some speed surveys. So we're gonna go ahead and say add. And I'm just gonna assign one for the entire thing of 100 kilometers per hour. Click add.
Sorry, Professor, I have a question real quick.
Yes.
For our project, we have to assign like speed for every segment. Like we have to do the design speed and the posted speed. It could be the same, like can be the same. Like we need for every segment because you put the ending and start for each point.
Yes, so for your project, you are going to assume a difference of 20 kilometers per hour between the design and the posted speed. Desired speed will be 120 for all of you. The design speed is going to be 80, and posted speed can be maybe 70. It depends. I think I had a file where I put the speeds, no? Just give me a second. I'm just gonna pause the recording, but I continue here. So I'm gonna share again. And we were here. Okay, so we entered the desired speed, 100 for this example. And now we're gonna enter the roadside hazard rating. The roadside hazard rating is on the roadside, if you have clear, flat terrain, then it's a 1. But if you have a lot of traffic poles, lighting poles, signage poles, maybe abutments, maybe some manholes or some structures or stuff like that, then it will increase, because if you leave the road, you will hit one of them. So for the analysis, we're going to take the midpoint. We're going to go with a 4, and we're going to say add. Okay, say close. Now, can you notice that all the check boxes are green now? That means that all the information we need for the design consistency analysis is good. If you were running a different analysis, then you will still have some items that you will still need to go and define, right? So say lighting, you will have to go and say add, and you will have to go say, yes, there's lighting from this place to this place, close, and now it's a checkbox. And driveway intensity and driveways per kilometer. So maybe we have 5, you say add, and you say close, and you will have to fill up everything, okay? But the one we're doing today is the design consistency, because that's the one we covered in the class on Tuesday. So we saw how to do this by hand calculations. Now the software is gonna do it for us. Is everybody here?
Yeah.
So please save it. So file, save. Once you have saved, you can close it. And now we're gonna go here and run the evaluation. If you close the evaluation menu, for some reason, you can go and invoke the evaluation by making a right click on the file you are doing, right? So you can go here and select the new evaluation, but in my case, it's open already, but you will select the second item. We're gonna select the design consistency, which is this one here. We're gonna keep the minimum and maximum, so the bounds for the entire alignment, because we're interested in the entire alignment. If you need to, you can enter here an assessment and you say, this is an existing highway, or you can say, this is a new highway design, conceptual, or final, or whatever. That's not really important. What is important is you select the right type of evaluation you want. So design consistency, and please click next. These are the type of vehicles. I don't remember, to be honest with you. These are passenger cars, but it is different levels of familiarity of the driver with the road environment. So I cannot remember if the one is here. Maybe it's vehicle type, maybe it's here. Okay, so passenger car type is the default, has the highest acceleration and top speed of the vehicles. So it's the most aggressive driver. And passenger type 1 has the lowest acceleration and top speed, and is a small proportion of the car population. So it's somebody who drives very smooth and slow and carefully. All right, so let's go with the type 5. Design versus operating speed. Predicted a speed differential of adjacent elements. This is what we did in class on Tuesday. I hope you noticed that. So we are gonna check the box for that. And we're gonna say next. We can adjust the maximum if you wish. No, we already selected, so we cannot change it. We're just gonna say next. And we're gonna be ready here to run. Just make sure you select show report on run completion so that the report will open automatically. Otherwise, you will go here and say show report on the left menu once it's finished and click on run. If you are running 30 or 31 or 29 kilometers, then it might take a little longer. Evaluation completed. So in my case, it's complete. So I'm just gonna say close. And in a few seconds, the report will open. While this opened, were you guys able to run the analysis?
Yeah.
Yes.
Okay, good. In my case, my computer is a bit old, so probably that's the reason why it's taking some time. So I'm just gonna wait. Maybe I close some stuff in the meantime to don't use RAM, but that shouldn't make a difference. Maybe the RGIS. Sorry guys, nothing I can do, I need to wait. There was one of you who was having trouble adjusting the ending station. Were you able to correct that?
The table of the data, you mean?
Somebody was having an issue and was trying to, because he was using a different computer, to ask for a few minutes to be able to switch computers, so we'll show the error message.
Okay, no, everything's good. I was able to get it.
Okay.
Thank you.
Okay. Yeah, did you get the report, guys? In my case, it's still running.
Yes.
Okay, so if you got the report, you can go ahead and have a look. You will see some graphs, and the graphs will have colors and flags. So if you have a red flag, it's inconsistent. If you have a yellow flag, it's fair design. If you have green flags, then it's consistent, it's good. So whenever we have those red flags, that means we have to go and either drop the speed or change the alignment if it is a design. If it is a existing road, then you might need to drop the speed there or put some additional safety hardware. You will have to do something because it's resulting in consistent. In my case, my computer is stuck and it's not showing me anything. Let me try to open here. I don't know why it's not opening. Let's try to. Okay, I'm gonna open a PDF maybe. Okay, so apparently opens. So let's see. It's not letting me go down. Okay, here. All right, so you should be able to see something like this, guys. Of course, but the road I design is very simple, right? So in my case, I just have increase here, but it's not that bad. From something like 65 maybe. 268 and then 277. So, okay, it wasn't that bad. Any of you got a full 20 or 29 or some kilometers that can show us something with red flags? In my case, it's not that illustrative. Otherwise, I can open a different report from something else.
I can show mine if you want.
Yes, please. I'm gonna, who was speaking, sorry?
It's Jean-Michel.
Jean-Michel. I'm gonna make you co-host. From now on, you are on charge. You can share, please. Ah, interesting. You have few red flags and yellow flags. Exactly. So it is changing from something like 90 kilometers per hour to something like 65. So that's a 25 kilometers per hour change there, the first one. And then the second red flag is also from 110 all the way down to maybe 88, something like that. So yes. So you can see how it will indicate what sections are inconsistent from the design consistency from the speed profile perspective. The other thing that you could notice, if Jean-Michel maybe can use his drawing tool there, you have, okay, nice. But you can see you have one drop that goes from 110 with a yellow flag, like on station, maybe 5+000 station, I think. So it's going from 110 down to maybe 92, and it's a yellow flag. But then has a little flat and then drops again to something like 88. So this is something exactly that one. This is something the software is not capturing because you have a little piece that goes straight and immediately drop the speed again. But you should consider the whole segment as a one drop from 110 all the way to 85 or 87, something like that. So it is quite important as well. So remember, this is an existing road, and on purpose, I am giving you guys something that is not very nice, right? That has a lot of curves. I did that on purpose so that you could get something that is not very consistent. Thank you, Jean-Michel. If you wish, you can stop sharing.
Yeah, you're welcome.
So were the rest of you, were you guys able to obtain the report?
Yes.
Okay, there are other items on the report. We did not fill the vertical alignment, if you remember. So once you put the vertical alignment, it might give you other things. Right now, what we did was to assign it was flat. Remember here in vertical, we assumed this was pretty flat, but that's not reality, right? So once you put the PIs here, then it might come back with something a little more inconsistent. From ArcGIS, you cannot read PIs because it's flat. So we're gonna have to wait until we arrive into Civil 3D next time so that we can create a surface and we can put an alignment, and then we can know what are the PI elevations, location, grades, and lengths. So that's why for now I put a 0, but we will typically get this from ArcGIS, okay? Question? Arash, if the question is for me, you let me know on a PDF here. You come here. I'm just gonna close this one. You come here to the evaluation, okay? In here, and you have the short report, and then you have an option that is PDF. Oops. And then you click on that option, and that will open the PDF for you. And then, of course, you can go and save it wherever you want to save it. Now, the warnings. The warnings are, this is an oversimplification because we're assuming this is perfectly flat. So we have to actually go and obtain the grades as I showed you before. This is not the purpose of today's class, okay? So this I'm gonna show you now is not for you to learn how to do it. All I want you is to be familiar with this tool to enter the highway. So remember, you can edit the highway here. And there are other type of analysis that we can run as crash prediction if you wish, in which we have to enter the different type of information that is there. So once you have entered all the info for the other type of, oops, sorry, forgot to say. But once the rest of the analysis are the same, that's what I'm trying to show you. You need to enter all the information and don't have any red X. Once that is the case, then you can run analysis for that specific item. So if you want to look at an assessment for crash, I'm not sure it's going to work, but let's hope so. Yeah, maybe not. Okay, but the point is, guys, you enter the info for the other things and you can run the other type of analysis. Yeah, it's beyond the limit. The maximum limit is 17,000, that's why. Okay. The same, you can go and obtain the report for crash prediction, and it gives you graphs. You can see the graphs also directly in there. I didn't show you that. So it will tell you the number of crashes that is being predicted. You can see on the curves, we expect more crashes, okay? You can see the graphs here as well. So this is a bit stiff at software, so it's not that friendly. You probably noticed that by now. Bear in mind it's free. It is used in the States. So if you end up working on the States, chances are you will have to deal with this. Oh, yes, I wanted to show you here. Maybe this one. Just give me a second, it's loading. Okay. I think I'm gonna have to use a different computer next time. This is very slow. Okay. So next time, and this is just for the purpose of the vertical alignment in the Interactive Highway Safety Design Manual. I will show you how to create a surface. like this. And then I will show you how to go and in that surface, put an alignment. For now, I'm just gonna put any alignment, okay? So forgive me. So when you are going with a specific alignment, I'm doing something horrible, right? I'm doing exactly what you are not supposed to do with an alignment. I'm going all the way up to the top of the mountain and all the way down, and then again all the way up. You typically do something else. You stick into the contours. I will explain that later. But the point is, from this alignment, we can obtain a profile, and then from the profile, we can obtain the values that will go into the interactive highway safety design manual. So let's give me a second, please. I click on that. Okay. Okay, put it there then. So this that you have here can be exported as a report here on the, I think it's on the toolbox, report manager. Okay, sorry, maybe you don't see what I'm saying, but the vertical alignment is here. You will have here the ground, and then you will bring the alignment here. Okay, I'm just gonna assume the alignment goes up to there. Here you have your curvature and you have your grades. And you will have your PIs as well. So when you are only designing the road, or when you take the values of something that is existing and you come here and you input, then you can then produce a report. So you can report the alignment, the curves, or you can just take it from here directly. Because in here, you will have to go in the vertical alignment and you will have to add your PIs. And you will have to define from what station, what is the back grade. Well, in this case, there's no back grade because it's the beginning of it. There's no back length. But the forward grade there is, so you will put there your 184% or whatever that happens to be, and then you will measure whatever that distance is, and then you will go and add it. And you will go like that if you go into a tangent, maybe if you're going flat. So you will add from what point, and you will complete this in a way in which eventually you have done it for the entire alignment, and then it's going to look like this one. So it's going to look like this one, in which you are going to have your points of vertical intersection with your back grades and forward grades. So for now, we cannot do it. So for now, we have to content ourselves with just assuming that it's flat, because that's all we can do from the ArcGIS. So the rest of the time that we have, guys, is really for you to work on your specific project. So I'm going to stop here. I wanted you to have the idea that this is a process that will continue evolving. So we will arrive into the ArcGIS next time, next Friday. So next Friday, you will learn how to create a surface. And I will start showing you some stuff in ArcGIS. No, pardon, in Civil 3D. So for now, we are assessing that existing road. We're assuming it's flat, which is not true. But we don't have a way to extract information from ArcGIS for the points of vertical intersections and the grades. We need to wait for Civil 3D to be able to extract that info and then put it back. So if you have already your Excel spreadsheet for this road segment for your final project, then I'm expecting you to work on that. So please give it a try and let me know if you have any difficulties. From the perspective of the class, that's about it for today.